Okay, so and I think I have Eclipse. Actually installed in here now. Actually, I have both, so if we get to it, they're all installed now. Okay, so last time we reviewed our primitive types and let's see what else we talk about. Whether or not we care about speed, whether we care about memory footprint, and the answer to both of those was kind of like a maybe. Okay, it really depends on the situation. So we need to know enough about these things and know enough about tools that we can use to combat these things so that in the situations where we do care about speed or we do care about memory footprint, that we can take the necessary actions to combat that, right? Make things more efficient or make things more speedy, and a lot of times those two are in conflict with each other. So that doesn't mean it always is, but more often than not, when something becomes more memory efficient, it also becomes less fast. All right, at least that's certainly the case with many of our data structures we're going to talk about. All right, so we talked about some of our early data structures that we've been introduced to. So even though we didn't specifically call them by name as a data structure, we have up to this point looked at arrays, and the book had introduced last semester this idea of an array list. And the array list is kind of like the thing we buy off the shelf at Home Depot, and it acts a certain way, but we don't necessarily know for sure how it's implemented under the hood, right? We don't know if it's officially implemented like a linked list or if it's implemented as a destructive array. For all we know, when we append something to an array list, it literally destroys the underlying array, building a new one that's one size bigger and putting copying all the values over to that. And now you have a new array. Now, if that was the case, let's go down that path. If array lists were implemented as destructive arrays, where if I had 5 things in the array list and I added a 6th, under the hood, it literally destroyed the 5-bucket array. Well, it literally created a 6-bucket array, copied everything from the 5-bucket array over, added the new element, and then destroyed the 5-bucket array. What would be the advantage of it working that way? What would we gain from array lists? There's 2 things I can think of that we would gain if array lists were implemented as a destructive array. Go ahead.
It would be a little bit faster when you were going to access something because you'd just be able to go to the next.
Okay, so searching through the data would be faster. Okay, what else? What else do we gain?
Wait. Change the scroll or sync the size of the array list.
Well, we already changed the size of it when we added the value. All right, so I'm the guy implementing the array list, and I'm deciding, okay, do I implement this guy as a linked list, whatever those are? At the very least, we kind of suspect they're probably memory efficient and slow. Okay, they're those guys. Okay, we can go that route, or we can make these guys memory inefficient and fast. Okay, so she already pointed out that if I choose the destructive path, I gain the benefit of it being faster when I search crap. What about when I add stuff to it? Is adding stuff to a destructive array list, an implementation of array list built on destroying the underlying array, is that going to be fast or slow? It's going to be slow. Okay. So when would we want to do that? Maybe when we are going to search the data more often than we add stuff to it. That might be a reasonable reason to destroy the stuff. Because in real life, it would never make sense for us to, if we want to, we want to add a sunroom to our house. It would never make sense for us to build a brand new house that's a little bit bigger, but it's identical in every way. that's a little bit bigger so that you can put the sunroom on there, and then destroy the old house. Right? Now, sometimes people do move for things as like little as sunrooms, but they probably at the same time will look at what else they can gain from the new house, right? What else can we pick up as we do the move? But, you know, generally speaking, it would never make sense for us to go ahead and knock down a house to add a new sunroom, right? Usually you find, you look at your yard, you figure out, well, what can I squeeze into this space, right? And then you just make it happen. Well, unfortunately, it doesn't work for us with arrays because they're specific in size. Is there anything else we gain though when we purposely make an array list based on destructive arrays besides speed? What about negatives? So we said that the cost of adding something to the array list is greater. So we certainly wouldn't want to do that if we were adding stuff often. Okay, so adding takes more time, but searching through takes presumably less time based on our current understanding. If you were implementing array lists, how would you implement this guy? And why? From our perspective last semester, what was the advantage of an array list?
Not limited to how many buckets.
It could grow quickly, right? We can add stuff to it. We didn't know how it was implemented under the hood. We just knew if we wanted to add something else to it, it wasn't a problem, right? Or at the very least, it wasn't our problem. All right? Who knows what was happening underneath the hood there? All right? So that's what's good about it for us. In fact, most of the time, we didn't care about speed or memory efficiency, right? We didn't notice. Who cares? Yeah, those are those previous couple of slides. Most of the time. Okay, but we knew that we would use an array list when we didn't necessarily know how many things we needed to store, but we wanted to have that convenience of being able to just add something when we wanted to add something. Fair enough. So if you were implementing array lists, how would you implement them? Let's say right now I gave you a homework assignment to write the equivalent of an array list. Is that where? I didn't store it there, did I? Didn't I store it like in my Dropbox? Or at this point, is this all made up? This one? No. Is it original awesome fat? Ah, nailed it. I want to have to do that again. Okay. Let's upgrade my... All right, so let's say that we were building our... We'll go ahead and create a new Java project. We'll call this guy CSC300 Spring 2017 array list. Okay, so we got this guy right here. We'll go ahead and create our new class. We usually call our guy with main init driver. And we'll go ahead and let it write our main method for us. And then I'll fix this because I hate the way it indents. Just make sure everything's connected up and running. So there's our hello. Seems to be a working version of Eclipse. Didn't it used to like put the stuff down the bottom? Ha! Nailed it. I'm so easily entertained. All right, so now we're going to go ahead and we're going to create our class. And let's create a class. And we're going to call this guy Arraylist. Because we already know that there's a thing called Arraylist, right? Now, when we build an Arraylist, initially, so I come in here, I'm going to say I want a Arraylist. We would say I want an Arraylist of strings, right? Something like that. And this guy is going to be called AR. It's going to be a new Arraylist of string. Something like that. And it's going to want me to import java.util, which is where Arraylist lives. What's this guy called? What's that an example of in Java? Is that required?
You're specifying your data type.
I am specifying my data type. So first of all, we see it's not required. It's kind of warning us, right? But it's not an error. If I don't specify my data type, what would be the generic data type? Object. Yeah, so if I'm not more specific, this guy knows how to hold objects. Okay? But if I go back to the specific, does anybody remember what this is called in Java? It's a generic, yep. These are Java generics. All right, so just a fancy name for saying we can conveniently manipulate this class so now it knows how to store that kind of stuff so that when we retrieve things from it, it gives it to us as, in this case, a string as opposed to as a object that we would then have to typecast back to a string later on. Okay, and we're not really going to focus on the generics aspect of this right now, but we're going to focus on if I were to give you an assignment to implement an array list today, how would we write that guy? Now, under the hood, when we have an array list is what are some of the features, the common features of an array list that we need to have? Okay, we got to be able to add crap. All right. What else?
They'll be able to find it.
We at least need to be able to get something out of place in it. All right. So we make our little list here, and we say array list. We have to be able to add stuff. We need to be able to add index, something like that. What else? Now, array lists have lots of things built into it. I'm kind of looking for what's our bare minimum to make it useful for us. What else should an array list let us do?
You have to know how many items are in there.
Yeah, maybe a count. Okay, well, I think array list has what size, I think is what it was called. Okay, the size of it, and Swift, it's all the collection types, so it's count. So you choose your poison. It's the same thing. Okay, so we need to be able to get the size, number of elements. All right. Maybe removing things would be helpful, but maybe that's a little bit lower on that priority list. Maybe we're just never going to get rid of anything. We'll put it in and we'll make sure we have access to it. I don't want to spend too much extra time writing this. So if we can build it, put stuff into it, get stuff from a certain place in it, and have it advertise how many elements are in there, that gives us some sort of utility with that guy, right? It's kind of like an array at that point, right? Does the array features stuff. Fair enough. But with the advantage that we are not limited by the size, right? Okay, we're not limited by the size. So we can add something to the end of it. Or at the very least, like I said a few minutes ago, it's not our problem, right? All right, so I'm building my A list here. How are we going to represent our data in our array list if I were to give you this assignment today? Is it fair to say that an array list is, or in our case, an A list is a collection of values? Okay. And for us, just to keep things simple and make it equivalent to kind of what we were dealing with over on the array list side, why don't we just assume that A lists are capable of holding strings? Okay? We will eventually get into generics this semester, but I don't want to muddy the water with it right now. This guy knows how to hold strings, and we're going to say that's good enough. In Java, being a string-based language, if we could hold something as a string, we can turn it into anything else, pretty much. Okay? Worst case scenario, if we want to hold other kind of objects in here, we can hold JSON strings. JSON representations of those objects. Not the most convenient thing in the world, but we could pull it off. Okay, so with that in mind, if we take our glasses off and look into the mirror, we can argue that our A list has great utility. All right? So I need to hold a collection of strings. What are our options? Use an array. Okay, anything else? There's really, okay, well, first of all, this goes back to last semester where we said we always solve our problems in terms of the tools that are in our toolbox, right? And right now we have a limited number of tools in our toolbox. So, I mean, we can make the assumption there's probably some good ways of solving this, but maybe ways that we don't necessarily have access to right now. Okay, if you're going to build a shed and you have limited dollars to go and buy a bunch of crap at Home Depot, you're going to go and root around in the garage, see what you have on hand, and figure out how can I build a shed with that, right? Sometimes you have to dismantle other things. Like when I do add stuff to my boat, sometimes I don't want to go and buy new wood. So I look at something else that I'm not using. I dismantle that and I use that wood, right? And then I get the saw out. My wife gets nervous. Because guys with saws, it never ends well, right? So you suggested an array. What else could we use that's in your toolbox? Well, let's say the toolbox that I've taught in class. Because some of you have done things outside of class. There's an obvious answer that isn't the way we're going to go, but we might call it cheating. Could use an array list built for holding strings and just pass the buck. You want to add something? No problem. Just append it to the array list. You want to know the size of it? No problem. You ask the array list. So we're not going to do that, though. We're going to build this in terms of arrays so we can appreciate that destructive thing. All right, so at this point, in terms of our tools that are in our toolbox, the way we know to hold collections of things in terms of us implementing it is really an array. All right, and because I've said we're going to store this guy as a specific type, it's going to be an array of strings, we're not going to have to deal with generics with this guy. Okay, so in here, I'm going to have a private attribute. Now remind me, with objects, all objects contain three different kinds of things. What are the members of an object? Well, I already mentioned attributes are fields. What are the other two? Fields, constructors, methods. Okay, so we're going to have a field here. We're going to call this guy, we just call it data. All right. And we'll start that guy off. Actually, this guy's going to be a string array called data because we're in a strongly typed language. All right, but it doesn't have a value yet. Then we're going to go ahead and build our constructor. Now in Java, constructors must be what? What does a constructor look like in Java?
They name this class.
Okay, name equals the name of the class. And what else?
Public.
They don't have to be public. You can, they would, if you leave nothing on it, then it's the package level security, but you could make a protected constructor that is only usable by children of the class. That would be reasonable. Yeah.
The new keyword?
Not when we're defining it. Yeah. We see the new keyword when we're creating instances of objects. So when I'm defining a constructor here, you mentioned that it's going to be have the same name as the class, so we'll go ahead and do that. We're going to have some parameters, whether we take anything in there or not. So we have a parameter list.
Void return.
Okay. Is it void?
No, well,
No.
nothing.
No return
Yeah.
type. No return type for these guys. And I'll go ahead and make it public so you're happy. All right. So this guy looks a lot like a method, but it's not. Okay. This is a constructor. And we know it's a constructor because the name of it matches this guy up here. And there is no return type. Now, why isn't there a return type? Maybe Van has some insight into that, given your answer from a minute ago. Why is there no return type for constructors? That would probably be involved, seeing so I brought it up. Now, when you mentioned the new keyword, I said, well, we don't see the new keyword when we're defining a class. We just see that we would see the new keyword over on this side when we do something like, we'll say, a list, LST is equal to new a list, like that. And you mentioned this thing about the new keyword. Based on that, why is there no return type right here? This was all material from last night. We all remember that, right? Huh? So now you're just making stuff up? Ah, Bakari, you're here. Were you here last class?
Yeah.
Were you lying? Really? I know he was gone. You tried to say your name this morning. It didn't come out right. Is your name Bakari or Bakari? How'd you say it?
Bakari?
Yeah. Is it Bakari or Bakari?
Bakari.
Bakari. Yeah, I mean, that makes sense, right? So he's just making made up words. I get it. All right. So constructors, besides having identical names to the name of the class, and that's Java specific. Not every single language requires that the name matches. For instance, in Swift and Objective-C, it's always like init something. You know, you could just choose the name of it. Doesn't matter. All right. But Java and C# both require the name to match the class name, which is kind of a thing. Not a big deal. Okay, but we do not have a return type here. Although in an older language like Objective-C, we do have a return type. It's redundant. We have a return type called an ID. What it really is, it's a pointer to a generic memory address. Well, Java has said, well, you know what? Why should we waste our time writing characters there when 100% of the time, when we use that constructor, it's spitting back a memory address? Because that's what the new keyword does. A new keyword is our real estate agent. It goes and finds a place in memory big enough to hold one of these dudes. Make sense? So since it always returns a memory address, we don't need to write some characters there to define that it's going to return a memory address, which is good news for us because Java has no syntax for representing pointer types, right? We don't have the ability to say this guy returns a memory address. It doesn't exist in Java. As opposed to when we first talked about the evolution of C++ to Java, I said that a lot of Java textbooks say that pointers don't exist in Java, when the reality is almost everything in Java is a pointer. Therefore, we don't actually have a specific syntax for working with them. We see crazy memory addressy looking things all the time. All right, so because we always see the new keyword when we're using constructors when we are using them, Van, that's why when we're defining the constructor, we don't have a return type. Okay, and we said we're going to define this guy in terms of a array of strings. So when we first create an array list, or an A list, sorry, first create an A list, how many elements are in it? None. We haven't put anything in there, right? So we're probably going to go ahead and say this dot data maybe is equal to null. The value actually defaulted to null, but as I said last time, don't rely on default values. If you explicitly want it to be nothing, set it to nothing. Okay? Now, we could do that, or we could be mean. All right? And we can do something like this guy's going to equal a new string array of size 0. That's accurate. There's nothing wrong with doing that. Well, not that there's nothing wrong with doing that, but why would we be better off saying this dot data is equal to null as opposed to this dot data is equal to new string array of size 0? What's the disadvantage of this guy right here? Go ahead. It's gonna make a memory address for it. Okay? It just is gonna give you a base address and not claim anything beyond that. So you're making the system do some work for some memory that's useless. Make sense? So it's now we can hope that Java is smart behind the scenes and say, okay, well, this guy tried to make an array of size 0, so let's just treat that as if he said null. We can hope, but we don't necessarily know. Right? We could test it. So let's do that. Let's just make that package level for a moment. Come out here. So help me. So my code's currently written like this. I want to test what the value of data is after I've instantiated it with this constructor. How would I do that out here? Here's my code. I want to test what the value that's in data is. I want to see, is it a memory address or is it null? See how smart Java is. Well, how have we viewed memory addresses in the past? If I create an array and then I print out the variable that holds the array, I usually see crazy memory addressy looking thing, right? So you're probably going to do some printing. Okay? Specifically, what am I going to print? What am I interested in printing? It's a lively group today. You didn't all over break just practice programming daily? No programming? None? Zip? Would you believe I was in Florida for almost 2 months and I programmed daily?
I watched some Swift videos.
That's it? You just watched, were they my Swift videos or other? Oh, well, so doesn't those don't count. Actually, that's kind of sad now that I mentioned it, that I was in Florida for 2 months and I programmed daily. That's sad. Like pathetic, right? Now I feel bad about myself. I'm interested in the value of this dude, right? So after I call upon the constructor, and the constructor does his constructing stuff, right? I want to go ahead and I want to look at what is inside the value of data. I'm really looking for two different values. I either want to see that Java was smart and said, look, this is useless, dude. So I'm going to make that null for you. Or we're going to see that Java was dumb and said, look, you asked for it. This is what you get. Okay? Any predictions? How do I get at that value?
Well,
I want the value of data.
normally we would say we want to use a getter.
Well, as the code is currently written.
We just say list.data.
Yeah, I specifically took the private off of this guy so we didn't have to use a getter to get at it. Okay, so we'll add the private back in. Actually, let's just put the private back in and let's be good programmers. Okay, so we'll do that. And just as a review, let's go ahead and generate our getters and setters. So you go to source.
Without private, is it just assumed public pretty much?
It's assumed to be package level.
Package, okay.
So anything that is, in this case, part of the default package would have access to it. What is it? Source, generate getters and setters, blah, blah, blah. And we'll go ahead and just give ourselves a getter for that guy. All right, so there. I hate that. How do you format your curly braces? Like this or like this?
Like that.
Like this?
Yeah, that's how they do it at work still. I need to follow there.
No, I get it. I get it. Do you know why they do it at work that way?
I don't know why they do it that way.
Which do you prefer personally?
Personally, I actually prefer it with it on the same line there.
Okay. Do you know what the rationale is why people started doing it this way?
I've heard it, but it's been a while.
So it's interesting. You remember from last semester?
I don't know if, so this is my take on it. I don't know the actual answer, but
Well, I did teach it last semester.
I don't remember it.
I usually spend a day going off on a rant on this.
So, I mean, that's how code is auto-generated by most IDEs. So one day, Trey Mitchell showed me some code, and I was like, "Oh man, you put your curly bracket on the same line," and I was like, "I don't like that."
Mm-hmm.
And then he was like, "Well, why do you put it on a separate line?" And I was like, "Because Lippman does."
Because Lippman said so.
I had a guess it would come from back in the days when however many lines of code you had could make a difference.
That's almost right. It is the number of lines of code, but it has nothing to do with lines of code in the actual program. Now we digest most of our knowledge digitally, right? Well, when you had programming textbooks, every line counts. So they had to squeeze it down as tight as it can get to fit more stuff on one page. And then that became habit, because that's what people were presented all the time. And then people started doing it all the time. It's not that it's horrible, but when you have lots and lots of code, being able to see where it begins and ends with everything indented in the middle, I think looks a little cleaner. I mean, we're not talking about like life and death type stuff. Okay? But the reality is it's very interesting to me that that this happened, right? Now, what's funny is now at work, does work make you write it like this? Or it just happens to be that's how everybody does it, so you've just kind of acclimated?
That's how everyone does it. I think if I did it differently, they probably wouldn't like it because they like us to all indent everything the same so that when you're looking at the code, it's really easy just to, because it's all the same.
Okay, yeah, sure, fair enough. So I'm trying to think about people that I know from the programming world that prefer it this way besides me. And what's kind of interesting is I've been programming for a couple of days, and I started programming when I was 9, which was really before books that taught programming were prevalent. See what I'm saying? So I didn't learn from a book. I don't even remember how I learned. I don't. Well, I would have been from a book. I really don't remember how I learned. I might have just been born this way. But yeah, it's very interesting. Well, I prefer it that way. I don't care how you write. So it's you're not going to lose points for anything. But I'm just for some reason it just bugs me that it's whatever. All right. So because we made this guy private, we gave him a getter. We'll go ahead and out here and we'll say lst.get data, and that should get us our value for that string array. And this is going to print out the value stored in that string array, which is not the contents of the string array, but rather the value of that variable, right? Okay. Now, it's going to be one of two things. Well, at least that's my guess. It's either going to be null or it's going to be crazy memory address. If Java is being smart, it's going to be null. If Java is doing exactly what we told it to do, it's going to be a crazy memory address. You have any predictions? Think it's a memory address? Anybody want to take the null side of the bet?
Tyler Martinez would have done it.
Yeah, Tyler would have. I yelled at him yesterday for not taking his class, and then he said, well, he has an art class. Yeah, he's taking it with his girlfriend. Young love. Although I should make fun of him. My wife drags me to those painting. I had to ship a painting home from Florida because I went and she took me one of the paint night things. We were doing like this, like a sun with like trees and stuff, but I turned the sun into Pac-Man. And I had ghosts. Like, oh yeah. All right, so you think memory address and nobody else wants to challenge you. We got a memory address. crazy memory address, dealy flippy. So does that mean that Java's wrong? I said if Java was smart, it would turn it into a null.
Garbage in, garbage out.
Did Java screw up here? Or did Java do what it should have done? You think it did what it should have done? Why? It is. Exactly. It is. That's what I told it to do.
Well, it's also if you say if you're creating an array with 0 buckets, you could do something with that. In theory, I mean, if in my add method I wanted to create a new array with 1 more bucket than I previously had, I could use that. But if it's null, I can't use that as my base for adding 1 more than was previously there.
Well, I could use this so far as saying how many elements do you have, and I would need 1 more than that.
Yeah.
So I guess with that in mind, well, you know what? That's actually not a horrible point. So if we come here and we do the add method, we say, public, actually I'm in the wrong class here, right? So we come in here, we do our public void add, and this guy takes a string s as a parameter, and let's just say add always adds it to the end of it, just in our world here. If we have it implemented as a string array, we don't have to do an if else. If we had it implemented as a null, we would have to say if it's null, create a new thing with 1 bucket, set bucket 0 equal to this. Otherwise, we could just say create a new array of size, whatever the current array size is plus 1, copy current array over to new array, and then tack on to the very last bucket. What's the position of the last legal bucket in the array?
Size -1.
Array's length minus 1. Yeah, the 1 minus the size of it because it's 0 indexed, right? All right, so we'll go ahead and we're going to create a temp array. So we're going to say string array temp is equal to new string array of size this dot data dot length plus 1. So it's 1 bigger than the current guy. Then we want to go ahead and copy everything from the current guy into the new guy, right? Okay, so we'll say for int I is equal to 0, I is less than this dot data dot length, I plus plus, and we'll say temp at bucket I is equal to this dot data at bucket I. Now remind me, is the this dot required here?
In that case, probably no.
Not required? Should I use it?
Yes.
Why?
So if you use it, you get IntelliSense to help you out if you don't know your.
Ah,
But
she used my answer. Yeah, then I don't have to worry about misspelling it. There's actually even a better reason for using it.
it also helps if you happen to accidentally create another variable that's local to the method and scope and identifies which.
Okay, well in that case, you have to use it.
Oh, yeah.
Yeah, in that case you have to use it. Yeah, so when we talked about scoping last semester, if we have a local variable here named data and we want to refer to the top guy, we need to specify. Do I mean the most local? Remember, all variables resolve to their most local definition. Right, so if I want the global one as opposed to the local one, I need to specify. But is there another reason besides IntelliSense and besides you have to use this dot?
Faster in theory.
It's faster. Why? Why is it faster?
It's not going to have to look for another definition.
Yeah, when we resolve variables resolve. When we have a variable, it's going to look in the local scope first. When it doesn't find it there, then it's going to go outward to the next, more global scope. When I say this dot, I'm giving it like the full path to this variable. I'm telling it exactly where you can go and find it. So technically, the resolution of that variable will be quicker. Again, imperceptible to a human if you're, if it's happening 1 off or 10 off or 1,000 off. But if it happened a billion times, you might start feeling it. Okay, but the point is it's important for us because that 1% of the time, let's say, or the 5% of the time, when we do care about speed or about memory, That's when we need to go back to this under the hood type knowledge and know kind of what's at our disposal for making things better. How can we make certain parts faster? How can we make certain parts more memory efficient? It's these little factoids that most of the time, actually factoid's the wrong word. You know what factoid actually means? Like, you know what I meant when I say factoid, right? I saw it in one of these puzzle things that talks about, words that people say all the time that doesn't mean what you think they mean. I think factoid means a false fact. Yeah, I'm pretty sure. So, I'll still say it, factoid. So, knowing these tiny little idiosyncrasies might benefit us in the future. So that's why I harp on them. I keep bringing them back up. All right? Most of the time, it won't matter. So, now my argument would be, if you mean the global guy, it is never, ever, 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 ever wrong to put this dot in front of it. And since putting this dot in front of it always makes it faster and always gives you the advantage of IntelliSense, there's not a good reason not to put it, except you have to type a few extra characters. But with IntelliSense, chances are you're actually typing fewer characters because you're letting it do most of the typing for you. Right? All right. So we created a new array that's a little bit bigger than the old one. We copied all the crap from the old array into the equivalent buckets in the new array. After we're done with that guy, we can expect that there's one little empty bucket at the end of the new guy, right? And we want to go ahead and put our brand new value S in that empty bucket. Where's the location of that empty bucket? Temp at bucket what? Where's the last legal bucket in temp? Temp.length -1. And we're going to set that guy equal to S. Are we done? At this point, we've wasted our time. What haven't we done? What actually needs to alter here when all is said and done? I built my new sunroom. Okay, my wife decided, hey, I want a sunroom. I liked my house, but apparently there wasn't enough room for a sunroom. So we went over here, got a brand new house, just tiny, tiny, tiny bit bigger. It's identical in every single way, but now I need to put the sunroom on it. So I've done that. So now I have two houses. I have my house without a sunroom, and I have my house with a sunroom. So now I'm moving over there. Right? So I actually have to go over there, which means I have to change my address. Right? So I need this data to no longer be equal to what it used to be equal to. I now need it to point to the same place that temp points to. How do I do that? Okay, so let's pause it for a second. Right off the bat, most of you are trying to think about this and thinking that, oh, this must be complex. The answer must be difficult, right? Let's draw a picture. So here's my variable data. And this is a we'll just say it's memory address 100 for no good reason. Easy math. Okay, and this guy technically points to somewhere where there's nothing. Okay, so we'll just put gibberish in there. Let's see if autocorrect gives me a real word. Okay, there we go. So it's pointing to some crazy memory address, although that's not really a memory address. I've used things greater than A through F, but A, B, C, F2. There. Hexadecimal memory address. Perfect. It's useless. It points to a real place, but there's nothing there. Then I have a array called temp. And this guy has some string in it, whatever S was equal to. And let's say this was at memory address 300. So I built temp. I copied everything over from data, which was nothing because data had length nothing. Then I added my string s to this guy. Maybe it's a, smiley face. All right, so I added my one string to the end of temp. But now, before all is said and done, I need to change my address. I need to do this. How do I do that? I want data to equal the same thing as temp equals. So data equal to temp. So temp's value is not this array. Temp's value is whatever's stored inside of its bucket, which is, in this case, by my drawing, 300, a memory address. Right? So I want to change data's memory address to be equal to temp's memory address, which then disconnects this guy. Let's go ahead and do that. So I'll say data is equal to temp. So now both of those guys point to the same place. Now when this method is over, what happens to this stuff? What happens to this memory address that was being held for us by the operating system? Go ahead. Yep. So pointer count for that guy goes from 1 down to 0 because one thing used to point to it. One thing used to point to it, but now that one thing points to something else. So this guy's been abandoned. Nothing points to it now. So its pointer count went from 1 to 0. Now Java has automatic garbage collection, so we have this garbage truck that's driving through memory and looking for things that nothing points at, and it cleans it up. Gets rid of that stuff. There is overhead with that, but we figure computers are pretty fast. Let's go ahead and let Java do that. There is a way in Java to turn off automatic garbage collection, which then requires us to call delete on an object so that it will disappear on its own. So that we force it to disappear so we don't have that extra program scouring memory, but let's keep things in reality here. But at the end of the day, now both of these guys point to the same place. Now what happens when my add method ends? What can you tell me about this picture upon the end of my add method? Who? Two things that point to the same memory address? There's only one object at that memory address, but two different things that point to that memory address? Nope. There is right now. But as soon as the method ends, that changes. It has to do with scope. I'm talking about scope. What happens when that method dies? Temp dies with it. So temp served its purpose. It was built in the moment. It pointed to something that was very useful for us. We just happened to preserve what it pointed to right there at the end. But when this method ends, temp goes with it. Does that mean that this guy's going to get automatic garbage collected? Why? Still something pointing at it. Counter went from 2 to 1, not to 0. We're still cool. Still have our new data. I have my new address. But from our external person's perspective, data is one bigger than it used to be. Make sense? Even though behind, under the hood, massive things were destroyed. Well, not massive in this case. You went from you went from a street corner, I guess, to maybe a Maytag box. Hung out behind a Walmart, and you got I haven't got the sunroom yet, is what I'm saying. We're building up to the sunroom. Okay, so that's our add methods. That'll give us one more thing in there. Now, we decided you wanted to have a size method. Okay, what kind of value should size return? int. Okay, so we'll go ahead and make it public. And we didn't have to make it public, could have left it as package level, but we'll make it public. Public int size, does it take any parameters? Does the size method need anything in order to do its job? What is its job? What ultimately is the size method going to report back? How many characters are in the string? No. Close. Not how many characters are in a particular string, but how many elements are in our string array, right? How many elements are in our actual string array. So this guy is going to return this dot, data dot, length. The size of our string array, which may or may not have previously been modified by add. Now getting back to an earlier question, had we originally set data to null, we would have had to ask a question in here as well. We would have had to say, if this dot data is equal to null, return 0. Else return this dot data dot length. Is one better than the other? So maybe this looks a little bit less stupid than it used to look. It used to seem pretty dumb that we did that. Why build an empty array? Are you an idiot? But now it's like, oh. In the right light, this makes some sense. But more importantly, and I liked his answer. What was your answer, Victoria? We told it to do it. And what's important about that? What's important about Java doing what we tell it to do? It's predictable. Okay. Programming's hard enough as it is, right? Or hard's maybe the wrong word. It's cryptic enough as it is. But one of the things that I've harped on it all last semester and semester before that is we need to be able to look at code and understand what's actually happening, how it's resolving, what a piece of information actually boils down to. Okay? We need to be able to trust our instincts when we look at it. And if we have to ask the question, what is Java going to do in this situation? If there really is truly a coin flip, then we start losing our confidence in being able to trust if what we say will actually get carried out, right? So if we can trust that Java doesn't make any judgment calls, doesn't say, look, stupid, I see what you're doing here. Let me do it better. We can trust that Java doesn't do any of that for us, then I think it gives us more confidence in what we write. Now, having said that, Java's very existence, though, was based on programmers making dumb. Remember when we talked about C++, we said that the C++ programming language, well, I mean, it's still used heavily today. In fact, there's nothing really wrong with C++ except for inexperienced programmers. Okay? C++ empowered programmers to do what? Do dumb things. The example I usually use is you're inviting somebody to a party. Okay, so let's say you're having a party tonight, but apparently not shoveling snow at my house, right? Yeah, I get it. So you're having a party tonight. What do? You walk up and say, "Hey, Mike, why don't you come over to my party? Here's my house. Open the door at 8." We would never do that in real life, correct? But in C++, you could choose to do that. You can choose to hand somebody the house. Now, I think it's fair to say that let's just randomly pull a number out of the sky and say 85% of the time when you write software, you're going to follow the way you would typically do things in real life. Most of the time, your real life problem solving matches up to your computer problem solving. But now, every now and then, it benefits us that we have some interesting flexibility in Java, right? Well, in programming. C++ gave us clean flexibility. Java, we kind of have to work around it a little bit, right? Because in C++, we had a special syntax for pointers. We can say, here is the address, or we could say, here is the value. We got to dictate that. Java doesn't let us do that directly. Okay? Java says, look, we're going to get rid of that syntax. We're not going to let you say that this is the address or this is the value. Some things automatically get passed by address. Some things, automatically get passed by value. All objects except for strings get passed by address. All primitive types, as well as strings, get passed by value in Java. Which means that if we have a player object like we were messing with last semester, right? And I hand you that player object and you change something in it, that change is global. Anybody who has that same pointer, because if I hand both of you that player object, you both have pointers to the same one place in memory, right? So if either of you change it, both of you will experience that change. That's the default behavior for objects in Java. It's also the default behavior for objects in C++. So C++ doesn't encourage you to screw up. But when you're a beginning C++ programmer, when you're a beginning programmer, you have kind of enough things to worry about, right? You know, every little missing semicolon or curly brace or something like that causes 30 errors. You start freaking out and you just randomly change stuff, right? You don't even read the error messages. It's like, oh, it's broken, change. It's like a moving target, right? Okay, so that's kind of the MO for beginning programmers. They're in that mode. It's a desperation type thing. They just keep changing stuff until it works, and then hopefully they look at it and try to understand why it actually works now. Well, in C++, even though the default behavior seems to be a reasonable behavior, because you're constantly grappling with, well, is this if we have a player object named P, is this star P or is it just P? What's the difference? Well, star P says the value at the address. P says, well, if you're dealing with an object, says the address. Similarly, if you have a primitive type, if I have an int I equals 7 and I say I, that's the value by default. That's the value of I. If I want to give it the address of I pass ampersand I. Here's the address where you can find that integer. So C++ gives you those extra little symbols that a beginning programmer might just randomly throw in front of stuff. This seemed to work last time. Let's do it this time. Make sense? But now, every now and then, let's say an advanced programmer in C++, they might turn around and say, you know what? I know in real life this would never make sense. Okay? But when I handed you that player object, I want you guys to both have copies of it. Okay? I don't want you to have the original player object. So if you make a change, I don't want you to experience that change. This is for you to keep. This is a present. Okay? In C++, we can do that. In Java, we can't easily do that. How would you accomplish that in Java?
Throw the player in another variable, give them that variable.
Well, you got to be careful though. If you have another variable, you throw the player into the other variable, you might be having another thing pointing to the same thing. Like yeah, they're different. Here's variable A, here's variable P, they both still point to the same place. So that's not going to fly. What can we do?
You have to create a new object, copy a new player, copy the values from the previous.
All right, so we're gonna create a clone, right? And we're gonna meticulously copy each value over. You got the same name, you got the same skill level. So yeah, here's my dummy. You get him. You get the original. You cannot tell the difference. These are not the droids you're looking for. Right? Now, Java does have a command that's part of object called clone. And that clone method that comes with all objects, what it does is it takes the memory and duplicates it in another place of memory. So you can say, clone, here you go, and those now don't point to the same place. They're different memory addresses. Is that better or worse than the C++ model? And there isn't necessarily a correct answer to that question. It's really maybe in the eye of the beholder, right? In C++, a lot of people who are C++ programmers today are either, well, C++ is still very popular. What is C++ still used for quite a bit today? Well, you can write Windows applications in Java. Business applications are great things for Java because it's platform independent. So when will we use C++ today? When you're trying to be cooler than the Java programmers, the Swift programmers, it would be really cool to use Objective-C. What's bad about Java? If you had to, give Java a demerit for something, what would you say is wrong with Java? What wouldn't you use Java for? Almost out of coffee. Good thing I brought it back up. Oh, by the way, I'm mad at you. You guys let me let you out 5 minutes early last class. It's 11:20, right?
Yeah.
I think I got confused. I thought it was I knew it wasn't a 50-minute class. I knew it was an hour and 15, but I did bad math or something. So today you're staying till noon. You what? Did you? Are you lying? Maybe I was thinking it should have been 11:25, but I'm still going to punish you. Punish 200? Well, I thought you were 200. See, that's how oblivious I am to reality. All right, so tell me, what wouldn't you use Java for? Who?
Video games.
Oh, why? Good answer. I love the answer. Why not for video games?
You said it once,
I said it once. I mean, really, everything that comes out of my mouth is gold, so shouldn't you just memorize it all?
You have to run it through the JVM.
Okay, Java goes through the JVM. What's the JVM? I've forgotten.
Virtual machine.
Java Virtual Machine. Why is that bad? Or why is that bad as it relates to video games?
Virtualization, virtual memory. I mean,
Slows it down. Why?
Because you have to go from whatever you're working on to the virtual machine and back to.
Okay, so remember way back when, in 200, there are two kinds of programming languages. We have compiled languages and we have interpreted languages, right? Okay, well, Java kind of acts like both of those. So Java is compiled in that we run it through the Java compiler and it translates that high-level language into a low-level language. It just so happens that low-level language is Java bytecode. And who interprets Java bytecode? The Java virtual machine. And the Java virtual machine converts Java bytecode into, almost all the time, since we're almost always dealing with Intel processors now, into Intel-based assembly code for the particular operating system you're running on. So Intel-based assembly code that understands the system calls for Windows, or knows about the system calls for Mac, that kind of stuff. So we have a compiled portion where your Java program something happens to it. It gets converted from the high-level language Java into the low-level language of Java bytecode. But then that Java bytecode is convertible or is transportable. So we can take this and we can move it over to a Linux machine or to a Mac or to a Windows machine. And as long as we have a Java virtual machine on there, it knows this standard Java bytecode language and then converts it to a different low-level language, which is native to that processor on that operating system. That makes sense? So it's interpreted at that level during runtime, and it is compiled prior to runtime to get us down to Java bytecode. Now, our computers today are pretty fast, so from a human being, for most applications, business applications, stuff like that, we're not going to feel that speed. Slow down. Okay? But video games are a little bit more demanding. Okay? Every single minute, we want more explosions, more realistic, more everything. We will feel the speed. That's an example. That's part of that, 5% or whatever, where every little decision that a programmer makes in video games has to pay attention to speed. At the same time, every little decision that programmers make in video games has to pay attention to memory management. And that's especially true if you're writing software for console video games, PlayStations or Xboxes, because, it's less true today than it was, let's say, 4 or 5 years ago. because now they're coming out with like a PlayStation Pro, that has a little bit faster processor, stuff like that. But generally speaking, when you're writing software for the Xbox, let's just use a generic term, okay, the Xbox. The software you're writing needs to run on the Xbox when it first came out, as well as the Xbox that the person bought at Best Buy yesterday. It's got to run on both of those, right? Now, you might start having some software applications that come out for PlayStation that say that you have to have a PlayStation Pro to play it. But you have to suspect that most game makers, when they're making games, they don't want to sell it to that small percentage of the market that have the PlayStation Pro. They want to sell it to the zillions of people who have a PlayStation of any PS4 of flavor, right? Doesn't matter whether it was the white one that came with a certain game, or they don't have a Teenage Mutant Ninja Turtle. They should have a Teenage Mutant Ninja Turtle.
Like a branded console.
Yeah, branded console. I would buy that. I don't even play console games, but I would buy that. All the console games now are all first-person shooter stuff. I can't do it. I suck. I'm literally good at everything else except that. I mean, even my when I picked up distance running, well, not running, it's distance sprinting that I do, but it's, you don't do distance sprinting? It's a lot easier than distance running, because distance running, you try to pace yourself. With distance sprinting, you just want to get it over with as soon as possible. And I usually start at the top, so I do a downhill. That way, even if I want to quit, I can't. Just let momentum carry me through.
Just a steady roll.
Seriously, yeah, I'm kind of built for that. I can handle those kind of. As long as I can hit the ground relatively gracefully. After that, I can roll around. It's fine.
It's like how our running speed comparison in 325 is you versus Bolt.
Yeah, I could beat Usain Bolt in a race as long as I get a big enough lead, like at the finish line. Like right at the finish line. Yeah, put me right there. Okay, because my reaction time might be a little slower than his too. So I mean, when they fire the gun and we go off the line, I mean, I need to be able to have that wiggle room so I can get across the finish line before he catches up. Because I mean, he's pretty quick, right? Would you hear he lost one of his medals? Not because of him. It was one of the relay teams. One of the other people on the team tested positive or something.
Oh, really?
Yeah, he didn't. So I guess he saves face, but I think he's just one of those God-created creatures that he was just made for speed. I thought I was the same thing, but apparently God made me more like an SUV. So. All right, what was I even talking about before I talked about Usain Bolt? How do we transition to that? This happens, by the way. This is the thing. All right, take me back. Talk about memory, games, writing stuff for consoles. Okay, so we were talking about C++ when we would still use it. You mentioned video games. Okay, so video games, we want to have a lot of granular control over memory and over speed and things like that. Okay, so even though the language might be, maybe we could say C++ is a relatively unforgiving language. All right, it kind of relies on you knowing kind of the right thing to do because it's not going to make a lot of those decisions for you like Java might. So because of that, C++ is still a pretty popular language for video games, even compared to C#. Because C#, we can say, it really has a lot of the benefits of Java, but still gives us at least some of the flexibility that C++ had. They've given us back the syntax for pointers and stuff like that. But even there, it's only kind of a halvesy thing. C++, and even before that, C. I mean, C and C++ are the same language, just C++ is the object-oriented version of it, right? Which just means it comes with a piece of Tupperware called a class that we can stuff the wires into and say, here. Right? That's it. It's the difference between the two, procedural and object-oriented. But C++ is still popular because it empowers the programmer to make bad decisions, but it also empowers a good programmer to have a lot of flexibility on how they want to handle a certain situation. Right? That's why it hasn't fallen out of vogue, because it really still fulfills a major thing. Now, We said we wouldn't use Java for video games because of that virtual machine thingy, because it would slow things down. For most applications, it would be imperceptible to a human being. But for some applications, we would notice, like video games. Make sense? All right. So getting back to this, we have our size. We have our add method. We're doing this in terms of our string array data. What's the next thing we need to add to this? We decided that we need to have a, we need to have our get at index, and then as a lower priority, we need to have a remove at index. So that means in our code here, we need to have something maybe called public string get at index, takes an integer index. What bucket do we want to get it from? All right, and we could assume for now, for this assignment, that get an index, the index you pass it is a legal index. Okay, you don't have to do the error checking. It'll be something within the size. All right, not the best programming practice, but just to get us warmed back up, since all of you spent a copious amount of time over break programming. Then we're also going to have a public string remove at index. Now, the difference between these two, though, will be that this guy returns without removing the string at position index. This guy returns with removing and resizing the string at position index. That might be written kind of funky, but whatever. So this guy is going to go to bucket index, get that string that we're going to return, remove it from our internal array, resize our internal array to now fit the new data correctly, shifting everything after that guy back down one. That make sense? So this dude actually changes our internal structure. This dude gives us a peek at something in our internal structure. That makes sense? All right, so for Tuesday, finish that code, and what I'm going to do, rather than putting this guy up on GitHub, I'm just going to paste this as a snippet into Slack. You were able to get into Slack, right?
I haven't tried it, but I should be.
Okay, I think I showed you, did I show you the address?
No.
Oh, well, here, just in case. cuwcs.slack.com.
I'm on Slack with other things.
Yeah, but you'll need to go to there, cuwcs.slack.com, and then do create an account.
Well, I have a Slack.
Right, but you'll need to create one specifically for your,
She's part of Greg's.
huh?
She's part of the Greg's.
Oh, so she's already on the thing. Okay,
So I just have to find a class.
yeah, just go in there and find the class. I get what you're saying now. All right, so this is 300, you said, right? So in 300, I'll go ahead and we're going to do a code snippet. I'll paste that dude in there. And then we're going to say complete this for Tuesday. And I'll put the assignment up on Blackboard. Sound good? Questions, comments, concerns, bribes? All right, I got my extra minute back. All right, have a good weekend.